Good morning, everyone. I'm Maheswari, AP Department, R&D Engineering College. This video, we want to discuss about the subject High Voltage Engineering. The subject code is E8701 and the unit of dissection is High Voltage Testing and Insulation Coordination. So, in this particular unit, the topic of discussion is testing of transformer. So before going to testing of transformer, we must know what is a transformer, what are the different types of transformer, and we will move to the topic of testing of transformer. So a transformer is a device which is used to step up the voltage or step down the voltage. So transformer is a device that transfers electric energy from one alternating current circuit to another circuit. It is used for different purposes to reduce the voltage of a conventional power circuit to operate low voltage devices. Say, for example, for the toy electric trains and for doorbells. And it is used to raise the voltage from electric generator so that the electric power can be transmitted over long distances. So the types of transformer, as already told, it is step down transformer and step up transformer. And we have seen the application viewpoint of it. Now we'll move to the topic testing of transformers. So what is the requirement for testing any equipments? That is the necessity of testing. So here this unit is the testing of different power system equipments. Now we'll see what is the need for testing. The high voltage testing of any electrical apparatus it is necessary because in order to ensure that the electrical equipment is able to withstand the over voltages. Whatever voltage we are applying, it is able to withstand it. And these over voltages may be either due to natural causes like lightning or switching or high frequency transient voltages. So in this testing of transformers, the transformers will get damaged due to transient over voltages or which might be either of lightning or power frequency. So over voltage test is important in the testing of transformers. So the different types of tests are induced over voltage test, partial discharge test and impulse testing. Now we'll see the first topic, induced over voltage test. So in this induced over voltage test, the transformers are tested for over voltages by providing or exciting the secondary of the transformer from a high frequency AC source to twice the rated voltage. Now this test is used to find or reduce the core saturation, limit the charging current necessary and check the insulation withstand test. So this is the induced over voltage test. Next one is partial discharge test. So in this partial discharge test, the winding of for the winding of the transformer, the test is carried out to access the discharge magnitude and the radio interference levels. So in this, the weak points in an insulation such as voids, cracks, and other imperfections which will lead to the internal discharge in the insulation. So these imperfections are leading to the power losses. So an electrical discharge that partial bridges the dielectric or insulating the medium between two conductors is called partial discharge test. It may be an internal discharge, surface discharge and corona discharge. So in the testing of transformer through partial discharge test, it is able to give information about the regions where there is more stress and imperfection in the fabrication. Now in case if the discharge magnitude is 10 power 4 or greater than 10 power 4 picocoulombs, when the applied frequency of the transformer, okay, by applying a frequency of the transformer, it is understood that it has failed when the the coulombs is 10 power picocoulombs. If the discharge magnitude is greater than this, then we say the transformer has failed. So this is about the partial discharge test. The next test is impulse testing of transformer. So the diagram shown in this PPT is the equivalent circuit of the transformer windings for impulse testing. So L represents the inductance and the CS represents the self capacitance or series capacitance and CG represents the ground capacitance or shunt capacitance. So this is the diagram for equivalent circuit of transformer winding for impulse test. So what is this impulse test? So impulse tests are used in transformer in order to determine the ability of insulation, whether it is able to withstand the transient voltages due to lightning. Now, by applying an impulse voltage, the distribution of voltage in the network will not be uniform and there will be an occurrence of oscillations. So, whose magnitude is higher than that of the applied voltage. So, this is the impulse testing and the procedure taking place in impulse testing have different points. First one is the impulse testing can be done with the following steps. First one is applying the impulse voltage of magnitude 75 percentage, which is of the basic impulse level under test, and one full length voltage of 100% of basic impulse test, two chopped waves of 100% of basic impulse test, and then one full wave of 75 percentage of basic impulse level. So in this manner impulse testing is done in the transformer. So here we are doing this test in order to find out the applied voltage wave and to determine the current through the winding and to determine the transfer voltage in the secondary and the neutral current. Okay. Now the next test is the diagram arrangement of transformer for impulse voltage test. Here you can see the windings. It is going to the CRO, and this is the capacitor which is represented as CS, resistance RS. These are the resistance RD. This is the winding of the transformer. Okay, primary winding and secondary winding, and the winding is connected to the CRO. This is the arrangement of transformer for impulse testing test. Next test in case of transformer is we have to understand the location of the fault and we have to detect the fault. So this location and direction of the fault can be done by the methods given here. First one is general observation. The noise in the tank or smoke or bubbles in the breather will give us an idea there is some failure in the transformer. This is the general observation. And voltage oscillogram method in order to detect and location of the fault in a case of a transformer. So in this method, the voltage oscillogram, we can able to complete during any. The next method is the neutral current method. So in this method, the fault is detected and the current flows through the neutral and the ground points. The ground, there will be high frequency pulses will be observed. Then we can find the fault condition. The last method is the transverse surge current method. So in this method, the voltage across a resistive shunt connected between the low voltage winding and the ground is used for fault location. Now in this case, the wave shape is distorted when there is any failure occurrence. So in today's session, we have seen what is a transformer and the different tests involved in the transformer. So first one is induced overvoltage test, partial discharge test, and impulse testing method. So these are the three different tests that has occurred in the case of a transformer. Thank you everyone.